Good morning students, my name is Manoj Sharma. So today we will study the application of Kohlrausch law. So there are 5 applications. First application is calculation of molar conductivity at infinite dilution, or you can say limiting molar conductivity for weak electrolyte. We know that the limiting molar conductivity of weak electrolyte cannot be calculated by the use of graph. Only strong electrolyte can be calculated. So it can be calculated experimentally or by the use of calculation. For example, we have CH3COH, weak electrolyte. So Kohlrausch law can be used to find out the limiting molar conductivity of weak electrolyte. This limiting molar conductivity of acetic acid is equal to the lambda naught CH3CO negative plus lambda naught H positive. This is the ionic conductivity. This is the limiting cationic conductivity. This is the limiting anionic conductivity. This is the limiting cationic conductivity. So the individual sum of anionic conductivity and cationic conductivity is equal to the limiting molar conductivity of weak electrolyte. This is the Kohlrausch law. So it can be calculated by the use of limiting molar conductivity of KCl, CH3COH and HCl by the use of Kohlrausch law. We know that limiting molar conductivity of KCl is limiting ionic conductivity of K positive plus limiting ionic conductivity of Cl negative. Similarly, limiting molar conductivity of CH3COK is equal to ionic conductivity of CH3CO negative and limiting ionic conductivity of K positive. HCl, limiting molar conductivity of HCl is equal to cationic limiting conductivity of H positive and ionic limiting ionic conductivity of Cl negative. So we have 3 equations 1, 2, 3. Now you see in our numerical we have to calculate the limiting molar conductivity of acetic acid, which is equal to these sum of these two ions. Now this CH3CO negative is present in equation number 2nd and this H positive is present in equation 3rd. It means we have to do the sum of equation 2nd and 3rd. So sum of equation 2nd and 3rd and equation 1 is not required. So जो हमें नहीं चाहिए वो minus कर दो. So sum of equation 2nd and 3rd minus 1st. So we will calculate the limiting ionic conductivity of CH3COOK plus limiting ionic conductivity of limiting molar conductivity of HCl minus limiting molar conductivity of KCl. This value is equal to sum of these two. This value is equal to sum of these two minus, and this value is equal to sum of these two. Okay. So we know that this minus is there. That's why this will be also minus. This will also be minus. So these two, this K positive and this K positive, this value is in the negative. This value is in the positive. So this and this will subtract each other. ये हम कैंसिल कर देंगे. This value is in positive, this value is negative. So this and this value will also cancel each other. So what we get? Lambda naught CH3CO negative plus lambda naught H positive. This is equal to limiting molar conductivity of acetic acid. So we can take a one example of one numerical. If the molar conductivity at infinite dilution of NaCl, HCl and CH3COONa are 126.4, 425.9 and 91.0 Simon centimeter square per mole respectively. What will be that of? That of means limiting molar conductivity of acetic acid, which is a weak electrolyte, CH3COH. So what is given? We have given the lambda naught CH3COH, lambda naught CH3COH is equal to, cap naught. Cap naught is the limiting molar conductivity. CH3COH is equal to lambda naught CH3CO negative plus lambda naught H positive. This is Kohlrausch law. In Kohlrausch law, the limiting molar conductivity is equal to individual sum of limiting ionic conductivity of anion plus limiting ionic conductivity of anion. So this we have to calculate. Now we have given limiting molar conductivity of NaCl, lambda naught Na positive should be plus lambda naught Cl negative is equal to 126.4 Simon centimeter square per mole, equation 1. Now limiting molar connectivity of HCl is equal to lambda naught H positive plus lambda naught Cl negative is equal to 425.9 Simon centimeter square per mole. This is equation 2. Limiting molar connectivity of Ca3CO is equal to lambda naught Ca3CO negative plus lambda naught Na positive is equal to 91.0 Simon centimeter square per mole. Equation 3. Now the question is how we solve the limiting molar connectivity of acetic acid by the use of 3 equation. Now see, we have limiting molar connectivity of acetic acid is equal to these two, sum of these two ions. Now where is this ion? In these 3 equations, where is this ion? It is given equation number 3. So I have taken equation number 3. Plus. Where is this ion? Ionic connectivity of H positive. Where it is? It is given in equation number 2. So plus 2 I have taken. Now afterward nothing is there. It means we don't require equation number 1. So that's why the equation which is not required, that will be subtracted from sum of equation 3 and 2. So 3 plus 2 minus 1. So it means 3 will be written first equation, then second will be written, then minus first will be written. How? So we have limiting molar connectivity of Ca3CONa, equation number 3rd, plus limiting molar connectivity of HCl, equation number 2nd, minus limiting molar connectivity of NaCl, equation number 1st. So this value is equal to these two, this value is equal to these two, minus this value is equal to these two. एक्चुअल में इससे पहले प्लस आना था, बाद में बाहर माइनस है, इसलिए अंदर क्या है माइनस हो गया. So this value is equal to 91, this value is equal to 425.9 and this minus, and this value is equal to 126.4. So the value will be 390.5 Simon centimeter square per mole. So by use of this you can solve the numerical of Kohlrausch law. Next is calculation of degree of dissociation. What is degree of dissociation? DOD. We have already seen the video of degree of dissociation when we are adding water in the weak electrolyte or strong electrolyte, then this electrolyte will dissociate. How many molecules were dissociated? For example, 100 molecules we have taken in starting, and how many are dissociated? That is called degree of dissociation. So degree of dissociation value is alpha. It is equal to cap MC. It means molar connectivity at any concentration, and this is cap M naught, limiting molar connectivity, that already we have calculated by the use of Kohlrausch law. So molar connectivity at infinite dilution, or other name is limiting molar connectivity. This is calculated by Kohlrausch law already in the application first. This will be given, molar connectivity of solution at any concentration C will be given. So one we have calculated by Kohlrausch law, second will be given, and alpha can be calculated. How? One numerical is given. Calculate the degree of dissociation alpha of an acetic acid if its molar connectivity is 39.05 Simon centimeter square per mole. Given that lambda naught H positive is equal to 349.6 Simon centimeter square per mole, and lambda naught CH3CO negative is given 40.9 Simon centimeter square per mole. So this is the numerical. So we have to calculate alpha. So first of all we will calculate lambda naught M for CH3CO. So lambda naught CH3CO negative, this limiting ionic connectivity of CH3CO negative is given 40.9, and limiting ionic connectivity of H positive is given 349.6. So when we add these two, when we will do the sum of these two, we will get the limiting molar connectivity of acetic acid. And limiting molar connectivity of this acetic acid we have calculated 390.5 Simon centimeter square per mole. And limiting molar connectivity at any concentration. Molar connectivity, you can see molar connectivity. Molar, calculate the degree of dissociation of acetic acid if its molar connectivity is 39.05. So its molar connectivity is given at any concentration, it is 39.05. So 39.05 will come on upper side and 390.5 will come downside. Why? Because this is, so I can write the formula also. This alpha is equal to lambda M divided by, not lambda, sorry, I always confuse with this. This is cap M, is a limiting molar conductivity at any concentration, and cap m naught is a molar conductivity at infinite dilution. The value of alpha will come 0.1. So now calculate all the numerical related to degree of dissociation. Now third application is calculation of dissociation constant of a weak electrolyte. So in +1 already you have studied in the equilibrium this Kc. What is this? Equilibrium constant is equal to C alpha square by 1 minus alpha. Alpha we already calculated. How we can calculate the alpha? Degree of dissociation. C is concentration of solution. Kc dissociation constant of weak electrolyte like acetic acid, ammonium hydroxide, that we have to calculate. So how we can calculate? We have a numerical. The conductivity of 0.001028 molar acetic acid is 4.95 into 10 raised to power minus 5 Simon per centimeter. Calculates its dissociation constant if cap naught for acetic acid is 390.5 Simon centimeter square per mole. It means cap naught limiting molar conductivity is given, then 0.001028 m, लास्ट में m लिखा है, इट मीन्स मोलरिटी. कंडक्टिविटी कप्पा 4.95 into 10 raised to power minus 5 Simon per centimeter is given. So kappa is given, molarity is given. So molar conductivity at any concentration can be calculated. So kappa value is 4.95 into 10 raised to power minus 5. Molarity value is 0.001028 and 1000 is multiplied. So the kappa m is 48.15 Simon centimeter square per mole. Now cap naught m for acetic acid is given. I already told 390.5. So cap m, what is cap m is 48.15. We have calculated at any concentration, and this cap naught m, the limiting molar conductivity or molar conductivity at infinite dilution, is given. So this value came 0.1233. Alpha is degree of dissociation. We know that CH3COH is a weak electrolyte. When it will dissociate in the equilibrium, in the starting, it will dissociate into CH3CO negative plus H positive. So at initial concentration, CH3COH was C and no product was there because reaction has not started. At equilibrium concentration, this C will dissociate out of C. How much this will dissociate? C alpha. C में से कितना टूटेगा? C alpha. और जितना टूटेगा उतना ही दोनों ये बनेंगे. So product concentration is molar concentration of CH3CO negative C alpha, molar concentration of H positive C alpha. So C alpha multiply C alpha dot C alpha. And this C minus C alpha can be written as C1 minus alpha. So we know that the value of equilibrium constant is equal to molar concentration of all the product divided by molar concentration of all the reacted at equilibrium. So both the products are C alpha multiply C alpha divided by C1 minus alpha. So C will cancel with C. So we have C alpha square by 1 minus alpha. So value of C is given 0.001028 and alpha value we have calculated 0.1233 square, because alpha का square है तो इसका भी square हो जाएगा. On the place of alpha, downside also 0.1233. So value we got, the value of this dissociation constant Kc is 1.78 into 10 raised to power minus 5 mole per liter. So this was the our third application and the numerical method. So you calculate all the numerical related to this. Now fourth application is calculation of solubility of separately soluble salt. ये separately soluble salt होता क्या है? The salt like silver chloride, barium sulfate, lead sulfate, which dissolve to a very small extent in water, जो बहुत कम dissolve होते हैं पानी में, are called separately soluble salt. As they dissolve very less, इनका मतलब इनका solution को क्या बोलेंगे? Their solution are called as infinite dilute, क्योंकि वो बहुत कम होते हैं, बहुत कम dissolve होते हैं. As their solution are saturated में बहुत कम जितना डिसॉल्व होना था हो चुके हैं. देयर कंसंट्रेशन इज इक्वल टू सॉल्युबिलिटी, तो उस समय उनकी कंसंट्रेशन को हम सॉल्युबिलिटी के इक्वल मान लेते हैं. सो वी नो दैट कैप m naught is equal to kappa into 1000 by molarity. This is the molar conductivity at infinite dilution. Okay, so cap naught m is equal to kappa into 1000 by solubility. I already told that molarity is a concentration, so molarity can be considered as the solubility. तो molarity को हम solubility मान सकते हैं, ठीक है, जब उनकी कंसंट्रेशन चेंज ना हो सैचुरेटेड सॉल्यूशन के ऊपर. सो सॉल्युबिलिटी को कैलकुलेट करेंगे क्या? कप्पा इनटू 1000 बाय लिमिटिंग मोलर कंडक्टिविटी. तो तो हमारे पास न्यूमेरिकल है, देख लीजिए आप. द कंडक्टिविटी ऑफ अ सैचुरेटेड सॉल्यूशन ऑफ सिल्वर क्लोराइड एट 298 केल्विन इज फाउंड टू बी 1.382 मल्टीप्लाई 10 raised to power minus 6 Simon per centimeter. Find its solubility. Given ionic conductance of Ag positive silver ion and Cl negative chloride ion at infinite dilution are 61.9 Simon centimeter square per mole and 76.3 Simon centimeter square per mole respectively. So what is given to us actually? The limiting ionic conductance of silver Ag positive, that is lambda naught Ag positive, is given 61.9, and limiting ionic conductance of chloride ion lambda naught Cl negative is the symbol, is given 76.3. So limiting molar conductance of AgCl will be the sum of these two. We know that the limiting molar conductivity of any compound is equal to the sum of the ionic conductivity of both the ions. So this lambda naught Ag positive is given 61.9, lambda naught Cl negative is given 76.3. So this will be equal to 138.2 Simon centimeter square per mole. Now conductivity is given 1.382 10 raised to power minus 6 Simon per centimeter. So we know that solubility is equal to kappa into 1000 by cap naught m. Okay, so this kappa is given 1.382 into 10 raised to power minus 6 into 1000, and this cap naught m we have calculated 138.2. So answer has come 10.5 10 raised to power 5 10 raised to power minus 5 mole per liter. So this 10 raised to power minus 5 mole per liter is multiplied by the molecular mass of silver chloride, 143.5 gram per liter. So while after the multiplication we can get the 1.435 into 10 raised to power minus 3 gram per liter. इसका मतलब 1 लीटर के अंदर सिल्वर क्लोराइड कितना डिसॉल्व होता है? 1.435 into 10 raised to power minus 3, which is very less. That's why these are called as a separately soluble salt. Now next, last application is calculation of ionic product of water. The limiting ionic conductance of H positive is given lambda naught H positive is equal to 349.8 Simon centimeter square per mole. Similarly, limiting ionic conductance of OH negative, that is the lambda naught OH negative, is given 198.5 Simon centimeter square per mole. So sum of these two ionic conductance is equal to the limiting molar conductivity of H2O. So this will equal to 548.7 Simon centimeter square per mole. And conductivity kappa for pure water is given 5.54 into 10 raised to power minus 8 Simon per centimeter. So we can calculate the limiting molar conductivity is equal to conductivity into 1000 by molarity. So kappa we know, molarity we know, so limiting molar conductivity we can calculate. Molarity is, we know that molarity is molar concentration of H positive or OH negative, you can say. If we know the molar concentration of H positive, OH negative, easily you can calculate. So molarity is equal to kappa into 1000 by cap naught m. Now kappa is 5.54 into 10 raised to power minus 8 into 1000, and lambda naught m, which already we have calculated, 548.3. So calculation will come 1.01 into 10 raised to power minus 7 gram ions per liter. Okay, so this value is equal to molarity. Okay, or you can say H positive or OH negative. Now this you can assume, or we can say that this is the value is the molar concentration of H positive. If this value is molar concentration of H positive, and H positive and OH negative both are equal, and they are equal to ionic product of water. क्या होता है ionic product of water? We have already studied in +1 class. Kw is equal to molar concentration of H positive multiply molar concentration of OH negative, and this value is equal for both H positive and OH negative. So this value is for H positive, this value for OH negative. When we multiply these two value, 1.01 into 10 raised to power minus 7 into 1.01 into 10 raised to power minus 7, this will come to 1.02 into 10 raised to power minus 14. So this is the ionic product of water. So we have studied the 5 applications of Kohlrausch law. So you can study all these and calculate the numerical related to all these. Thank you very much. So you can see all these videos of my whatever I have uploaded on this channel or the next topic what I will study will be related to the galvanic cell. Okay, thank you very much.